Okay, this is 8th grade lesson 4.4. The students will compare linear and nonlinear functions, so we'll kind of tie into what we did with the activity. The standard covered in this lesson is 8F 1, 2, 3, and 5. The page numbers out of the hardcover book are 168 through 173, and out of the practice journal, pages 89 through 92. Yesterday, we worked with graphing some information so that we could visually see linear versus nonlinear functions. Today, we're going to also tie into that, looking at some equations and being able to understand from just looking at an equation whether we are working with a linear versus nonlinear function. So first of all, let's review. We need to describe how we can tell the difference between a linear versus a nonlinear function. Well, linear has the word line in it. So if we are looking at a graph of a linear function, it is going to show a constant rate of change, a straight line when we get to see the graph. Okay, it's constantly going to do the same thing the whole way throughout the graph. The slope is going to be the same, and then also the change between every interval is also going to be the same. A nonlinear function, on the other hand, does not have a constant rate of change. So when it's graphed, it does not create a perfectly straight line. It might create a curved line, so we might see something that looks like this, like we worked with yesterday. It may show us something even like this as we get older and start working with some more complex functions. It could also show us something that would look like a V. The V is actually going to be represented when we work with absolute value. That's something that you'll work on as a freshman or as in Algebra 1, I should say. So non-linear functions are going to be a non-straight line. Yes, it's still a line, but it's no longer straight. Okay, so determine linear and nonlinear from a table. So when determining whether a function is linear or nonlinear, we're going to go ahead and look at our x and our y values, and we're going to identify what's happening between those. Now, yes, we could go through and graph these and see what the picture actually looks like, but there is another method. If they were to just ask us a question based off of the points that would be on a graph, we should be able to determine whether it's going to create a linear versus a nonlinear by looking at the rate of change. So we're going to go ahead and look at our x's here and see what's happening to get from the first x to the next, and we'll continue the pattern to make sure that the pattern is the same. So here we go from 3 to 6, so that would be either taking it times 2 or adding 6. So we're just, or not adding 6, adding 3, sorry. We're just going to go ahead and kind of take a peek at these, okay, and see which pattern continues if it does. So when we look at the next one from 3 to 6, or from 6 to 9, we're adding 3. So it looks like we're doing an add of 3 every single time. So the next one, does it still meet that sequence? Yes, it does. 9 plus 3 does give us 12. So it looks like we're adding 3. Now, in order for this to be linear, we also have to have the same pattern happening within the y's. Not necessarily the same plus 3, but we have to have a pattern that's consistently the same between each y. So here, when I go through and I check this, from 4 to 32, we would go minus 8. From 32 to 24, that again is minus 8. And from 24 to 16, we have minus 8. So when I'm looking at this table without having to graph this, if I see that the pattern is the same between all of my x's and all of my y's, then this is considered a linear function. Okay, so letter B, let's go ahead and check once again to see if we have the same pattern happening between all of our x's, and then also a constant pattern happening between our y's. So let's see, from 1 to 3, we would be adding 2. From 3 to 5, adding 2. And from 5 to 7, we would be adding 2. So there we've got a constant pattern. But once again, in order for this to be showing a linear function or a linear pattern, we must also have a pattern that is happening between our y's. So let's see, the first set we've got from 2 to 11, it looks like we're adding 9. From 11 to 33, we're adding 22. From 33 to 88, it looks like we're adding, 55. So we do not have the same pattern happening in our y's. So this would now be a non-linear pattern. Okay, yes, we have the same pattern up in our x's, But remember, you must have a pattern that is constant also between your y's. They do not have to follow the same pattern between x and y, but you must have that same constant function happening to each of those y's or each of those x's. Mainly the y's, because you can change your x's. Okay. You will notice though, as you get older, sometimes they skip values of x's. So if you were to check in a table to see if there is a pattern, make sure that the pattern in the x's is a constant pattern. Okay, because I could go through and like on this first one, maybe instead of skipping just 3, maybe I skipped 6. So maybe this would be 18. You would see a constant pattern. Also within the y's, it's just that there was a bigger gap here than 3. Sometimes that happens. Sometimes you have to see the graph unless you're really good with numbers and you can decipher that. But remember, you have to have a constant pattern between both your x's and your y's. Okay, so let's go ahead and try another one. So this is just where a table is set up slightly different. Instead of it being a horizontal table, it's a vertical table. So we're comparing our x's. So these are all of my x's here. I need to check the pattern on that. So it looks like we're adding 7, adding 7, adding 7. So we have a constant pattern in the x's. So now we'll check to see with the y's if it's constant. -5, -5, -5. So is this linear? Was it constant on both sides? Yes, so that would be a linear function. Okay, constant pattern is linear. Okay, so I want you guys to try these two. So remember yesterday that number 3, we don't have a picture. Okay, but yesterday you guys graphed some pictures and you looked at linear versus non-linear. So I want you to go ahead, pause your video, work your way through numbers 2 and 3, and determine whether these are showing a linear or a non-linear function. Okay, this one was showing linear. Okay, each of these was going down by 4 and each of my x's was increasing by 2. And number 3, well, this was nonlinear. Okay, this was actually showing us the picture. Yes, I could pull information off of there and do data points, but I don't have to. We can visually see that this is not a perfectly straight line. Yes, there are 2 straight lines, but this is considered one function. When I've got both of those pieces together, they create the one line. This would be a line that's it's folded, it's showing us a V, so this would be considered nonlinear. Okay, sometimes we're given an equation. So far we've worked with, in our activity, we worked with pictures and seeing the pictures of a graph. The slide that we were just on, we worked with data points or our coordinate sets, our tables, and we were able to determine from that. And now I'm going to go ahead and give you an equation. And there is a way that you can determine just from looking at an equation and not having to actually go through and substitute in for the equation. If an equation can be set up in slope-intercept form, that's that y equals format, then the equation is considered linear. So here we've got both of them that say y equals, but here's the thing that you have to remember. When we worked with the y equals format, we always had our slope with our x, and then plus or minus something in the back. It doesn't matter if we were adding or subtracting, but we were adding or subtracting a constant number. That number did not ever change, okay? So this one would show a linear function if we were to go through and graph it. Okay, and I could go through and actually demonstrate this to you. So let's say I just picked 3 y's, or 3 x's, I mean, just to prove to you what I'm talking about. So let's say for my x's, I wanted to use 0, 2, and 4. So notice how on each of these I increased by 2 every single time. Okay, and if I did 0, 1, 2, that's okay also. Now, just to make it easy, I did choose a pattern in my x's, but the key thing is that I have a pattern in my y's also. So if I were to put a 0 here, 0 plus 5 would give me 5. If I now put a 2 in here, 2 plus 5 is 7. Okay, if I were to then put a 4 in there, 4 plus 5 would give me 9. So you can also see that in this case, I ended up with an increase each time also of 2. Now, it's not always going to work out that way, but it did happen that I had the same pattern on each side. But once again, as long as your x's are constantly changing the same and your y's are a constant change, then that would be considered linear. The second equation that we have here, y equals 1 minus x squared. We have not worked anything with x squared before, okay? So just based on what you've previously learned, this would not show a linear function. It's going to end up being nonlinear, okay? To prove a point, let's go ahead and pick some x's. So we'll go ahead and do the same x's that I had over on my first one. We're going to do 0, 2, and 4. So if I put a 0 in here, 0 squared is 0. 1 minus 0 would give me 1. Okay, so now we're going to go ahead and put a 2 in here. 2 squared would give me 4. 1 minus 4 would give me negative 3. And now we'll go ahead and put a 4 in there. Okay, 4 squared is 16. 1 minus 16 is negative 15. Okay, so if you notice here, yes, it was a constant change of adding 2, because that's what I chose to do. But then my y's, when I substituted in, here it went down by 4. Here it changed by negative 12. So that was not a constant pattern, okay? So when we're looking at an equation, as long as it's in a y equals with an x and a plus or minus something, then it would be considered linear. As soon as they start changing part of that equation, it will no longer be linear. Okay, as you get older, you also work with absolute values. So as soon as they throw in an absolute value, it's no longer linear. Okay, so here's a real world application where we could see something that's linear versus nonlinear. So it says account A earns simple interest. Account B earns compound interest. So simple interest is you're just going to get so much interest each month or each year, however it's set up. Compound interest is where they're going to take the interest that you've earned the previous month or the previous year, and they continue to add that within. And so you're gaining interest on the interest that you previously earned. Okay. So it says the table shows the balance over 5 years, graph the data, and compare the graphs. So first of all, here's our first scenario. So in blue, I'm going to go ahead and graph this information. So for me, I'm just looking at this. I should be able to determine if I'm going to have a line or a curved line. So looking at this, let's see, all of my T's or my X's, these are my X's, all went up by 1, okay? Those were all increasing by 1 every time. When I look at my Y's, or in this case, they called them my, account A balance. I guess they did put a Y on my graph over here. So my Y's, looks like we increased by 10 every single year. So it didn't matter. I got $10 every single year for putting that money in there, okay? So if we go through and graph this information, we should end up with a straight line. Now, granted, remember I'm working off my smartboard and sometimes it's not perfect, but over to 0 up to 100, over to 1 up to 110, over to 2 up to 120, over to 3 up to 130, over to 4 up to 140, and over to 5 up to 150. Okay, so there's my simple interest, and I could extend that out. You could tell that at year 7, I will have $170, okay? So that's my simple interest. Okay, so let's go ahead and look at my compound interest. So account B, I still started out with $100, but in the second scenario, I'm getting what they call compound interest. So it's changing slightly. So yes, my X's, I'm going to cross these out. My X's are still going up by 1 every single time. That is not changing. My Y's, on the other hand, it looks like year 1, it was going up by 10. Year 2, it went up by 11. Year 3, it went up by 12, 10. Okay, so we can see already without even finishing that off that this is no longer going to show us linear. Now, it's going to be hard to see some of these because they're not a huge change, but by the time we graph out year 5, we're going to see a bigger change. Okay, so the first year, At year 0, we had started out with $100, so the same spot. At year 1, 110, that's still in the same spot. Year 2, we were at 121, so slightly above that. It's going to be kind of hard to see that. Year 3, 133.10, so somewhere in there. It's starting to go off of that line, but still pretty close. Year 4, 146.41, so 146 is a little above the middle. So now you can see at year 4, we're starting to see a much bigger gain. Okay, at year 5, it was 161.05. Okay, we don't see much change in years 1 through 3, but then by the time we get out to years 4 and 5, we can see that there is quite a bit of change. I can see that at year 5, it was what, like $11 more. Okay, so that was showing my compound interest. Okay, so graph the data, compare the graphs. So in our graphs, we notice that our simple interest is showing linear, a perfect line, and our compound interest was showing us a nonlinear or a curved line in that scenario. So key things out of this lesson, when looking at a set of data or graphs, or not graphs, non-graphs, but your data points like your X's and your Y's, as long as you have a constant change in both your X's as well as your Y's, then that would be a linear pattern. As soon as there's a change in one of your Y's or your X's, then that is going to be considered nonlinear or not showing you a straight line. When given an equation, a y equals format is going to show you linear. Remember, you cannot have anything other than multiplication and adding and subtracting involved in that y equals. So as soon as they do something squared or with absolute value, it is no longer linear, okay? Good luck with this, and just always remember, you can always revert back to graphing it out if you're a visual person and you need to visually see what that would look like. The unfortunate the downside to that is you're going to have to be able to set up your graphs in order to do that. So good luck with this lesson.